Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Picture this. It's 8:47 on a Monday morning. The CRM that 200 salespeople rely on to close deals. Totally unreachable. The new IT admin who promised a quick weekend cloud migration is staring at a login screen that won't budge, and the entire go-to-market team is idle. The culprit? A single misconfigured Azure network. This is part 1 of the Azure Networking Masterclass, a 16-part series that takes you from zero to production ready, starting right here with the invisible backbone that either makes or breaks every cloud workload. By the end of this video, you'll walk away with 3 concrete skills. First, you'll be able to name and explain the 4 pillars Azure uses to organize every networking service. Second, you'll know which connectivity option to grab when a boss says, "Make this hybrid." And third, you'll spot the silent cost trap most engineers miss, the one that turns a $100 app into a $2,000 bill. Think of your home Wi-Fi router. It helps your phone, laptop, and smart TV communicate with each other and reach the internet. In Azure, a virtual network, or VNet, creates a private network space for your cloud resources. But there is an important difference. Resources inside the same VNet can often communicate by default, even when they are placed in different subnets. Creating separate subnets helps you organize workloads, but it does not automatically isolate them. To control communication, you use tools such as network security groups, Azure Firewall, route tables, and private endpoints. The VNet provides the foundation, but secure network design depends on the rules and services you build around it. Here's a cloud scenario no IT team wants to experience. A company moved several servers into Azure and assigned public IP addresses to each one. Remote management ports were exposed, security rules were too permissive, and the systems were not patched quickly enough. An attacker found one of the exposed servers and used it for automated scanning, command and control traffic, and unauthorized workloads. By the time the company noticed, it was dealing with unexpected compute charges, outbound data transfer costs, and a serious security investigation. The lesson is simple. Cloud networking is not just about making systems reachable. It is about controlling exactly who can connect, which direction traffic can flow, and how that activity is monitored. Azure organizes its entire networking portfolio into 4 categories. First, the networking foundation, VNets, Subnets, DNS, the literal building blocks. Second, load balancing and content delivery, services that distribute traffic and make apps fast and available. Third, hybrid connectivity, the bridges between your on-premises world and Azure. And fourth, network security, firewalls, DDoS protection, and everything that keeps the bad guys out. Keep this mental model in your head. Every service we touch from here on out slots into one of these pillars. Let's ground this with a bank application. The VNet is the private network boundary that contains the workload. Inside it, you might create a web-tier subnet for application servers, an application subnet for business logic, and a data subnet for databases. Internet traffic does not reach a subnet simply because you call it a web subnet, Traffic normally enters through a controlled service, such as Azure Application Gateway, Azure Front Door, or a public load balancer. Network security groups then control which traffic can enter and leave each subnet. For example, the web tier might accept HTTPS traffic from Application Gateway, while the database subnet accepts connections only from the application subnet. That combination of segmentation, controlled entry points, and security rules forms the foundation of a well-designed Azure network. Quick check. A company places its web servers and databases in separate subnets inside the same VNet. Does that automatically block communication between them? The answer is no. Azure provides system routes that allow resources in the same VNet to communicate. Subnets help organize and segment resources, but you still need network security groups, Azure Firewall, or another security control to restrict unwanted traffic. Remember, separate subnets provide structure. Security rules provide isolation. IP address planning is one of the first major design decisions in Azure networking. A CIDR block such as 10.0 or C/016 contains 65,536 total IP addresses. You can divide that address space into smaller subnet ranges, such as 24 networks. A24 contains 256 total addresses. Azure reserves 5 addresses in every subnet, leaving 251 addresses available for resources. The beginner mistake is choosing an address range that is too small or overlaps with another network. That becomes a major problem when you later connect Azure to an office, data center, another cloud, or a second Azure VNet. Plan for growth, avoid overlapping ranges, and leave room for future subnets. Changing an IP design after production systems are deployed can be difficult and disruptive. Let's put the foundation into practice. In the Azure portal, select Create a Resource, search for Virtual Network, and start a new deployment. Name the network Prod VNet and select the correct subscription, resource group, and Azure region. For the address space, enter 10.1.0.016. That gives you a large private range that can be divided into multiple subnets later. Create a subnet named Web Subnet and assign it the range 10.1.0.024. Select Review and Create, verify the settings, and deploy the VNet. You now have the foundation for an Azure network. It is not yet a complete production design because you still need to consider security rules, routing, DNS, monitoring, private access, and connectivity. But every production Azure network begins with this basic structure. Let's lock in the subnet math. How many IP addresses are available for resources in an Azure.24 subnet? A24 contains 256 total addresses. Azure reserves 5 addresses for platform use, leaving 251 addresses available for assignment. That may sound like plenty, but some Azure services require dedicated subnets, and many services consume multiple addresses as they scale. Always calculate current requirements, expected growth, and Azure service requirements before choosing a subnet size. Imagine your application server connects to a database by using the hard-coded IP address 10.0.1.5. Later, the database server is replaced, moved, or assigned a different private IP. The application still tries to connect to the old address, and the service fails. DNS solves this problem by allowing applications to connect to names instead of memorizing IP addresses. Azure provides built-in name resolution for many resources inside a VNet. You can also create an Azure private DNS zone, such as internal.contoso.com, and use names like dbserver.internal.contoso.com. However, DNS records must still be maintained. A manually created A record does not automatically update itself when a VM address changes. You can use automatic registration where supported, assign a static private IP, or update DNS records through your deployment process. The important lesson is this: applications should depend on stable names, not fragile hard-coded IP addresses. Now, what if a private VM needs to download updates or connect to an external service, but you do not want to assign a public IP address directly to that VM? Azure NAT Gateway provides managed outbound internet connectivity for one or more subnets. The VM sends traffic using its private address. NAT Gateway translates that private source address into a predictable public IP address and sends the traffic to the internet. The external service sees the NAT Gateway's public address instead of the VM's private address. This is useful when a vendor needs to allow list your outbound IP. NAT Gateway supports outbound connectivity, but it is not a web proxy or security inspection service. It does not inspect URLs, filter destinations, or block malicious content. For outbound filtering and traffic inspection, you would use Azure Firewall or another network security appliance. When a workload inside a VNet needs to reach an Azure platform service such as storage or Azure SQL, two common options are service endpoints and private link. A service endpoint allows the Azure service to recognize traffic as coming from an approved VNet or subnet. Traffic travels across the Microsoft backbone, but the service still uses its public endpoint and public DNS name. Private link goes further by creating a private endpoint inside your VNet. That private endpoint receives a private IP address, allowing the workload to reach the Azure service through a private network path. Private link normally also requires private DNS configuration, so the normal service name resolves to the private IP address. Here is the important security detail. Creating a private endpoint does not automatically disable the service's public endpoint. For full private isolation, you must also disable public network access or restrict it according to your security requirements. Service endpoints are simpler and can be appropriate for many workloads. Private link provides stronger network isolation but adds cost and DNS complexity. Choose based on the sensitivity, architecture, and operational needs of the workload. Quick check. A private VM needs to download operating system updates from the internet. The VM should not have its own public IP address, and a third-party service needs a predictable source IP to allow list. Which Azure service fits this requirement? The answer is Azure NAT Gateway. NAT Gateway gives resources in a subnet scalable outbound internet access through one or more predictable public IP addresses. Remember, NAT Gateway provides outbound address translation. It does not provide application-level filtering or firewall inspection. Let's say your video streaming site goes viral. One little VM can't handle the traffic, and users get 502 errors. You need to spread the load. Azure Load Balancer sits in front of a pool of VMs, evenly distributing traffic using Layer 4, just looking at IP and port. It performs health probes to check each VM's health, and if one fails, it automatically stops sending traffic to it until it recovers. This gives you high availability with zero application changes. And you don't need to configure DNS TTL tricks. Load Balancer's front-end IP is the single endpoint users hit. Suppose your application runs on several servers. If you simply need to distribute TCP or UDP traffic based on IP addresses and ports, Azure Load Balancer operates at Layer 4. It is fast, efficient, and well-suited for many network-level workloads. But what if requests to DDoS images need to go to one backend pool while requests to DDoS API go to another? That requires Layer 7 routing. Azure Application Gateway understands HTTP and HTTPS traffic and can route requests based on the URL path, hostname, and other web request information. Application Gateway can also be deployed with Web Application Firewall capabilities. A properly configured WAF can help detect and block many common web attacks, including patterns associated with SQL injection and cross-site scripting. But WAF is not automatically included in every configuration, and it does not replace secure application development. Choose Azure Load Balancer for Layer 4 traffic distribution. Choose Application Gateway when you need regional web routing, TLS termination, or web application firewall capabilities. Most enterprises do not move every system to the cloud at once. They may still have domain controllers, file servers, databases, and legacy applications in an on-premises data center that need to communicate with Azure resources. A site-to-site VPN can connect those environments. An on-premises firewall or VPN device establishes an encrypted IPsec tunnel across the public internet to an Azure VPN gateway. Once configured correctly, on-premises systems can reach Azure resources through private IP addresses, and Azure resources can reach approved on-premises networks. But the tunnel is only one part of the design. The IP ranges must not overlap. Routes must exist in both directions. Firewalls and network security groups must allow the required traffic. DNS must resolve names across both environments. A VPN creates the path. Routing, security, and DNS make that path usable. When connecting a data center or office to Azure, two major options are VPN Gateway and ExpressRoute. Azure VPN Gateway creates encrypted IPsec tunnels across the public internet. It is usually faster to deploy and has a lower entry cost, making it a strong choice for branch offices, smaller environments, backup connectivity, and many standard hybrid workloads. ExpressRoute uses a private connection provided through a connectivity partner. The traffic does not travel across the public internet and can provide higher throughput and more predictable connectivity. However, ExpressRoute is more expensive, requires provider coordination, and may take longer to provision. Also remember that private does not automatically mean encrypted. ExpressRoute provides a private network path, but organizations may still use application encryption, MACsec, or IPsec when encryption requirements apply. Choose VPN Gateway when encrypted internet-based connectivity meets the business need. Choose ExpressRoute when private, predictable, high-volume enterprise connectivity justifies the additional cost and complexity. Quick check. Which hybrid connection avoids sending traffic across the public internet, VPN Gateway or ExpressRoute? The answer is ExpressRoute. VPN Gateway encrypts traffic, but sends it through the public internet. ExpressRoute uses a private provider connection. But remember, a private network path does not automatically guarantee end-to-end encryption. Always evaluate both connectivity and encryption requirements. Picture an online retailer during its largest sale of the year. The website is operating normally when it suddenly receives an enormous flood of malicious traffic. The goal of the attack is to consume network and application resources until legitimate customers can no longer connect. Azure includes baseline infrastructure-level DDoS protection for Azure services. For workloads that need additional protection, Azure offers paid DDoS protection options with enhanced monitoring, adaptive tuning, attack analytics, alerts, and support capabilities. Paid DDoS protection is not automatically required for every public IP address. The correct choice depends on the workload's business importance, number of protected public IPs, exposure, risk level, and recovery requirements. For a business-critical public application, DDoS protection should be part of the architecture review, not an afterthought after an attack begins. Here's a real NSG rule. We're denying all outbound HTTP on port 80 to the internet. Priority 100 means it's evaluated early. Direction outbound. It applies to traffic leaving the VM. And here's the part everyone misses. NSGs are stateful. If you allow a connection, the return traffic for that session is automatically allowed. No need for a matching inbound rule. An unassociated NSG is nothing more than a piece of paper. Open any NSG that shows 0 subnets, 0 NICs. It hasn't been linked to anything, so its rules don't apply. Click Associate, hook it to a subnet, and only then do those rules go live. Check the effective security rules on a VM to confirm you're protected. A developer launched a simple app, $100 a month on VMs. The next billing cycle, $2,000, all from data leaving Azure regions. Every engineer learns firewalls, but almost nobody plans for data transfer costs until the bill arrives. This is the silent budget killer. Azure network charges depend on where traffic starts, where it ends, which service carries it, and how much data is transferred. Outbound traffic from Azure to the public internet is one of the most common data transfer charges. Pricing is usually tiered by volume and destination. Cross-region traffic can also create charges because data is moving between different Azure regions. Here is an important detail. Keeping resources in the same Azure region does not make every network path free. Traffic across peered VNets can incur VNet peering charges, even when both VNets are in the same region. Traffic inside a single VNet is treated differently from traffic crossing a peering connection, gateway, firewall, private endpoint, or global network service. Never rely on a simple rule such as same region equals free. Check the pricing for the exact source, destination, service, and traffic path. Quick checkpoint. Does Azure charge only for outbound internet traffic? No. Outbound internet traffic is a major cost category, but charges can also apply to cross-region traffic, VNet peering, gateway processing, firewall processing, private endpoints, and other networking services. The correct question is not simply, is the traffic inbound or outbound? The better question is, where does the traffic begin? Where does it end? And which Azure services process it along the way? Here are 5 practical ways to control Azure networking costs. Number 1. Keep services that exchange large amounts of data close together when architecture and resiliency requirements allow it. Cross-region traffic can become expensive. Number 2. Avoid unnecessary VNet peering and complicated traffic paths. Peering, firewalls, gateways, and private endpoints may each add processing or transfer charges. Number 3. Right-size services such as VPN Gateway, Application Gateway, Azure Firewall, NAT Gateway, and ExpressRoute. Do not pay for capacity the workload does not need. Number 4. Use Azure cost management budgets, alerts, and anomaly detection so unexpected network charges are discovered early. And number 5. Measure traffic. Use flow logs, connection monitoring, service metrics, and cost analysis to identify which applications and destinations are moving the most data. Private networking can improve security, but private does not always mean free. Design for security, performance, and cost together. Take a moment. Two VNets are located in the same Azure region and connected through VNet peering. Is traffic between them always free? No. VNet peering can generate data transfer charges even when the VNets are in the same region. This is why architecture diagrams should show more than resources. They should also show the traffic paths between those resources. When an Azure connection fails, do not immediately start changing firewall rules and routes at random. Begin with Azure Network Watcher. Use Connection Troubleshoot to test whether a source resource can reach a destination IP address, hostname, or port. The result can help identify routing, name resolution, and connectivity problems. Next hop shows which routing destination Azure selects for outbound traffic. Effective routes shows the routes applied to a network interface. IP flow. Verify helps determine whether a network security group allows or denies a specific flow. For example, if traffic intended for an on-premises network shows an Internet next hop, a route may be missing or configured incorrectly. Use the tools together. Connection. Troubleshoot tests. Reachability. Next hop examines routing decisions. Effective routes shows the complete route table. IP flow. Verify evaluates NSG behavior. Troubleshooting becomes much faster when you test each networking layer systematically. The AZ700, Azure Network Engineer Associate, covers domains like core networking, routing, hybrid connectivity, and private access, exactly what this video covers. Head to the description for the official Microsoft Learn study path. Bookmark it now. Let's tie everything together. First, Azure networking begins with VNets, Subnets, IP address planning, DNS, and routing. Subnets organize workloads, but security controls determine which systems can communicate. Second, every connectivity service solves a different problem. NAT Gateway supports predictable outbound internet access. Private Link provides private access to Azure Platform Services. VPN Gateway and ExpressRoute connect Azure to external networks. And third, always design the traffic path before deployment. The path determines security exposure, performance, troubleshooting complexity, and cost. A strong Azure engineer does not simply ask, "Can these systems connect?" A strong Azure engineer asks, "Should they connect? Through which path? Under which rules? And at what cost?" Part 2 is where we really get our hands dirty. We're going to walk through VNet design and IP subnet planning step by step, so you can build your first production-ready network from scratch. Hit that subscribe button and ring the bell so you don't miss it. Check the description right now. There's a free subnetting cheat sheet waiting for you, plus the full Azure Networking Masterclass playlist. Real tools, no gatekeeping. We made this to move your career forward, not just to entertain you for 20 minutes. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.